All right, so here's the definition of an antiderivative. A function, be sure to capitalize it, capital F of x is an antiderivative of f of x on, well, let's make that an open, AB, if big F prime of x equals f of x for all x in the interval.
Wait, are those closed parentheses or open parentheses?
Open. Okay, so find two antiderivatives of cosine x.
Oh, this is where we had to add the constant, huh?
Yeah. Okay, so if you want an antiderivative of little f, big F has to be a function you take the derivative and it gives you cosine. Yeah. Okay, that's one. That's one possibility. What's another possibility? Yeah, any constant. Because if I take the derivative of constant, what's the answer? 0, right? So both of those are antiderivatives. Because if you take the derivative, it gives you cosine x, right? So
you just find things that
when you take
the derivative, it would be cosine x.
Right. Yes, that's an antiderivative. So you're basically going the other direction. Instead of going sine to cosine, you can go cosine to sine. Okay, what that plus 2 leads us to is something called the general antiderivative. Okay, we're going to be kind of floating in space here for a few days.
So whatever makes that derivative is the antiderivative?
Yes.
Okay.
Yeah. Okay, so there's a statement. F of x is an antiderivative of little f on AB. Okay. Every other antiderivative is of the form f of x plus a constant.
What is the difference between the capital F and the lowercase f?
f is the antiderivative. Little f is the original function.
Okay. Okay.
So big F is what you take the derivative of.
Okay. Wait, so big F, what do you take the derivative?
Yeah, f prime, big F prime equals little f. Okay, do you kind of get the picture here? Instead of taking the derivative of little f and getting f prime, we're taking the derivative of big F and getting little f. Okay, so we're taking a step to the opposite direction of a derivative. Here's a, do you understand the constant part? Why that works? Yeah. Okay, then I don't need to show you graphically. There's a graphical example in your book if you want to look at it. Okay, these are called formally an indefinite integral. Okay, so we will steer away from calling it an antiderivative. It's just a way to introduce it. We're going to call it an integral, and it's going to be written like this. The integral of f of x dx equals big Fx plus c. Means big F prime equals little f. So you can see the general antiderivative and the indefinite integral are the same thing. So this is our notation for it.
What is that different thing?
That is what we write for an integral. Okay. It's like saying take d over dx of f of x. Okay, that would be take the derivative. That s means take the integral of f. Okay. All right. So basically, a lot of definitions so far. Here's your first really useful piece of information. Okay, you know the power rule for derivatives? Bring it down and subtract one. Okay, well, what's it going to be for integrals? Put it up, add one, and divide by that number. So, you'll get it. You'll get it.
It's easy once you actually do like problems with it. I was reading something that said the equation of calculus, and it looks something like that, but I don't know if it's
Oh, fundamental theorem of calculus?
yeah, is that like the quickly thing in some equations?
The integral. Yeah, we're going to get to that in a couple weeks.
Yeah. This is like the major college. This? No. But this, I like this one more than
Okay.
I.
So,
I just don't like that. I can figure it out in this equation.
if I were, so let me kind of make this easier for you. If I were to take the derivative of x squared, what do I get? Right, because I brought that down, right, and subtracted one. Right? For an integral, I'm actually, instead of subtracting one, I'm going to add one. So this is going to be x cubed, and then I'm going to divide by that number. Okay. Yeah, it is. So you can see how they complement each other. What if I took the derivative of x cubed over 3? It gives you x squared. Okay, you can go backwards. Right? You shut up. Meanie heads. Just because you've done this before. Okay.
Oh, Ben Truett. Ben Truett. Truett.
You guys are awful.
So if I don't get this, then I'm just gonna move to Alaska and make goat herding. Yeah,
That's going to be a really hard life.
that's my second one. I know, but it's not.
Why will that be hard? Because goats are hard to raise in Alaska. Probably because you have to keep them in like an insulated.
Yeah, go to Africa.
All right, so let's focus up and finish. We're almost done for the day.
Simmer down, little one.
Okay.
Simmer down.
We're almost done for the day. I'm just giving you a little bit here. So evaluate the integral of 3x to the fourth minus 5x to the 2/3 minus x to the negative third dx. We can just take the integral of each individual term. So what is the integral of that?
3x to the fifth all over 5.
Yep. Add 1 to the exponent, divide by it. Okay. What's the next one?
Okay. So I went lost. I think it's the first term.
Okay.
All over 5.
Add 1 to the exponent
Oh, I was
and divide by that number.
Okay. That is second all over. Plus x to the negative 2 all over the negative 2.
I need one more.
Plus b.
Thank you.
Homie.
We will get to a point where the plus c falls away. They're called definite integrals. But for now, you have to include it. Okay, if I wanted to simplify this, if you want to rewrite it, what?
I'm making cheers more fun.
Do you think you can handle some work on this?
Yeah.
Okay.
Okay.
You want another one?
I want another.
Okay.
You don't have to simplify, right? It's not an 8.
It's a 1.
The ball's inside your mom, so if you have problems, everyone is talking. No, yeah. They're talking about how he gives the easy examples in the homework card, and I said, yeah, it has to be, but then we have to go home and do his mom with a spoon of toothpick, and the bomb's inside your mom. My homework was Okay, so.
It's really profound.
On the top one, how did you get rid of those denominators, the 5 and the 5/3? He's not supposed to get rid of it.
5 divided by 5/3 is 3.
But on the first term, we're not supposed to get rid of the denominator.
Oh, whoops.
Oh.
Oh, okay. I was like, what the heck?
My bad. Huh.
Why we don't simplify.
Where did it get wrong?
So now, yeah, I would have lost the point. No?
Yeah.
Just, well, I'd say you should, because on a multiple choice, it might be simplified. Okay, you need to be able to do it. Now on a free response, I say don't. No. Okay, so what is the integral of 9x plus 2?
9
9x squared over 2 plus 2x squared.
Keep going.
Let's see.
Okay, you got to think of this as x to the 0. So add 1, and then of course divide it. So if you took the derivative of the answer, it should give you the original. Yes. Okay.
So how did you go from? Wait, no, 2x. What happens to the 2x?
What about it?
It goes from 2x to 2x?
No, this was 2. I was telling you that's x to the 0. So you add 1, divide by 1.
So all numbers add on the variable?
Yeah, in an integral.
So
Yep.
is the B and C going to be our worthless quotient?
E, natural log, trig functions, and then initial conditions. We'll get to those later. They're honestly really awful in integrals. So, okay, here's the work.
Yeah, definitely going to go further.
Wait, we skipped 4.8?
Yeah.
Are we not allowed?
In your head,
There was
in your head,
one
have
series
heart attack
that-
on outside, you can keep having this-
One example.
and not happening there. The only thing I can do on all those
What do you need to do?
Okay, that's 3 days worth of work.
3 days for this lesson?
No, this lesson was 1 day. We have two more days of this section.
Oh, okay, well, you didn't put A. You just-
Sorry.
So this is just A.
All you have to do to appease Corey Hertz, say sorry, apparently. Okay, so this weekend, finish A and the spiraling because you have the weekend. Okay, Tuesday, we'll check it. You'll do part B. We'll check it, do part C. I want to make sure we're kind of taking care of business, right? Make sure we don't have any questions, so. Well, you have to own some goats, and you have to have a place to put them.
I'm going to raise why would you make it on a wire?
No, it's
Oh, you're
not
going to
one.
calculus for it? No.
You need calculus for those.
Not, and you calculus for those. You have to find the math with it.
You have to find out how much food you can give them without spending too much money.
I'm going to close the video down so people in the world don't think I'm a bad teacher.